Hello, welcome to part two of how we can use some more advanced programming patterns to sort of power up our game design. Power up, level up. It's game design, level metaphor. Okay. Uh, immediately lost my train of thought, but we're going with it. I made a few changes to the game since the last video ended. The last video on the command pattern. Uh, and I added the goal functionality. So we now have a goal script that and it has a collider and a goal layer. We have a goal layer, a block layer, and default. And then on the block, we have the block script, but we also have a goal target. I don't know, the name's not great, but a goal target, if all the goal targets are on all the goals, then we've won the level. The player also uses the block, and because I know that I like making variations on Sokabon, and in the future I might want to add more block types. Block would probably be on all sorts of objects that may or may not be goals. In traditional, just boring Sokabon like we're making here, we could have folded this goal target logic right into the block because they are always going to be the same, except actually not even here because the players a block for us. So to keep blocks is just things that control movement and move other logic elsewhere. We're going to do that. Different levels of prototyping, we can get away with different levels of generalization and abstraction. In my experience, it's nice to have our sort of base thing that moves on grid to be nice and isolated because we're going to use that a lot. So in this case, I've gone ahead and made goal target its own thing. But we could have had player, take some of the logical block or extend the block even. But we didn't. So here we are. The next thing I've done is because I have these objects all need to know about the physics settings, because I now need to be able to, the player needs to check to see if there is an object in front of it, but not check for the goal. And instead of some if-else thing where, okay, if I did hit something and the thing that I hit is a goal, then I can move. Instead, we're just going to use physics layers, and we're only going to look on the certain layers that we want to check for movement. So any block object needs those layers to check for movement. So it knows it can't move into walls, and it knows if it moves into a block, it may or may not be able to move, depending on if that block can move, and if it it can move into goal layers, right? So we made a scriptable object of type, we just made let's just call it layer settings. It's got these 3 public values. I made a game data folder and I put it in there and set them up. Then I went to my scripts folder and I went to my block and I set it up on the import settings of the script. I set that object up to be the default, let me change this one, to be the default property. So now, this is kind of like almost like a poor man's dependency injection framework. A little bit. When Unity creates the objects, it will give it this dependency that it needs. So if we make a block, look, it's already filled in. I don't need to do the 1-2 extra mouse clicks. So when you have things set up like that way, it makes this scriptable object workflow where you have like a game settings object that like everything needs. It makes that way more palatable. You don't have to like manually configure that. For us, because we're going to be using prefabs on just about everything, the goal, the block, the player, make a goal as well. On just about everything, it's even less of an issue, right? We're not, it's almost always going to be set up. So not too big of a deal to have that link that needs to get made. So let's check out our game. Our block can move and our players can move. We like that. Key them in. And we have this script on the block, on the goal target, called check for goal. And there's no goal there. But if I do move it on a goal and I do check for goal, I can darken the block and I have, in fact, landed on a goal. So let's take a look at that. The goal target script, all it does it calls this is goal here function and then changes the sprite. But here's the actual function we care about. It just checks to see if there is something on top of it of the goal layer mask. And then if there is, and it has a goal component, maybe we don't need that. Maybe we can just have an empty game object, but maybe we want that goal component to do something in the future, like light up, or who knows. It's good to have there just for future proofing ourselves. This script does nothing. The script it has a little debug error message if you don't have the layer set up correctly. That's all it is. It does not affect the game at all. Right. I wanted to put some bit masks, some more advanced little bit mask things in here just to have them as like a little hidden example that you can learn from. Okay, so we have this isGoal function. We have that check for goal that'll use that function and change its sprite accordingly. And we want to use that to see if all of our objects are at a goal. So how do we do that? Well, first we need the object itself to know if it's at a goal. Right now I'm calling this function manually, but I want to have the game call this function for me. So how can I have this function get called at an appropriate time so that the block will just update itself after I move? Well, the easiest way to do that is just to do it in update. Oh, I didn't leave play mode. This is a bad idea. Don't do this. But it works. It's just completely unnecessary. We're having this block every single frame, and our game is not frame based. Our logic, our behaviors of our game are not on a frame by frame. You know, we might be sitting there thinking for 10 seconds as we try to puzzle out what to do. And then now suddenly, we're checking for the goal. Let's not do that. Instead, let's use an event system so that we're only checking a goal when we need to. So let's go to the block and let's create a new event that the block will call whenever it is moved. So we're going to make a new public action. And this action is going to be called at new position event. Right? Add new position event, add new position event. Right? We're going to call it when we move. We're also going to call it when we undo. Interesting. Both move and undo use the same function here, move and direction. So we are going to say at new position event. If it is not null, invoke it. So because both the move and the undo and the push block commands all use this script, this is where it makes the most sense. This is where I'm actually updating my position. So this is where it makes sense for me to tell me I'm at a new position. This doesn't mean I have ended a move. It only means that I've arrived at a new position. So I want to keep my mind on that, on the fact that this can happen even if we haven't created a new turn. So you'll be careful what types of things you're subscribing to it. Okay. So in our goal target, we're going to now need a reference to the block. So we need a private block, and we will initialize that one in awake here. This now requires the block component in order to work. Void on enable and on disable. We will subscribe and unsubscribe to the event. So that is block.atNewPositionEvent plus equals check for goal and minus on disable. Great. So now we no longer have the update function going. So we shouldn't see 8 million messages in my console of that debug.log. We should see the sprite change color. It gets darker when we hover over the goal. And it works. And you can see we only check when we move. If we undo, it got brighter. So it we make sure we make the change both ways, right? We make sure our code is doesn't care about undoing and doing something and that difference, right? If it's playing an animation, then maybe we need to pay attention to if we are doing something during a movement or during an undo, so that we can only do the animation during movement, and we can maybe skip it or skip the sound during an undo, things like that. Something to keep in mind. But for our simple game, we don't need to keep that logic chained, right? In that case, in the block, we'd probably have new actions like move ended action or something like that, and then have those called by the commands. But there, now we have an event system that is updating our code, right? So I can add a goal target to a block, and it will subscribe to the events that it needs to subscribe to, and it will update itself at the appropriate times. We'll go ahead and get rid of that debug message. And if it's if there isn't and if there and we can remove this component, we can remove the goal target and nothing will break because the block has no dependency on the goal target, right? That event is what sort of flipped that dependency around, right? If the block said, okay, get component goal target dot check for goal, and it just does that after it moves, that would be perfectly functional. It would work perfectly fine. But I want to configure my game in a way where the goal target is not something the block needs. Instead, because that doesn't make as much sense to me. Instead, if we have the goal target or whatever other components that listen to that event, then they listen to that event. And if we don't have them, then no, maybe nobody listens to that event, and it's fine. And that's sort of the beauty of these events, is they allow our code to be way less interdependent, especially in situations like this where both of these objects kind of do need to be aware of each other. The goal needs to know when we move, and well, that's kind of it for this one, but you know what I mean. Especially something like player and player input and all those things. So now that we have the object updating, we need to be able to check if we have updated all of the objects in the scene. So I have one goal, but I want to be able to just hit duplicate and move and be done. You know, these aren't exactly at 0.5 and 0.5, and that was kind of bothering me in the previous video. Okay. Maybe I'll make the goal script. Maybe I'll add a snap to grid component and just give all of these snap to grid. Makes life a little bit easy. Maybe I will. I'll do that right now. No, I won't. No, I won't. Not important. Okay. So I want to be able to know if we should duplicate a block, and now we can, and the game should just work, right? Whatever is checking for if I have goals or blocks at all of my positions should just know. They should just have that information. So the condition that we're checking is if all of our goal targets are on a block or not. That is our condition. So how can we do that? Well, we need a game manager. The game manager needs to know needs a list of all of the goal targets, and it needs to know when to check them if they're all true or false. So let's start with the one place that's going to check our code. It's going to be a game manager. And we're going to make a new game manager script. And it's going to give us a fun new icon because there's a thing called the game manager in Unity version like 3 or something. I don't know. But it's just a script. We were allowed to call things this. All right. So we need to know when a turn is done. We need to, what else do we need to do? We need to know when a turn is done, and we need to know all of the victory conditions. In this case, the victory conditions are going to be a Boolean property of the goal target. So let's go ahead and save a public Boolean called @goal for our goal target. We should check for goal on start, right? You can have blocks that begin on the goal. They should just like be in the, they should do that on start. Okay. And then instead of saving that in a little temporary variable, we'll call that echo uppercase. And then I want this to, a fun new pattern. I want this to have a private setter. What's the syntax on that? Oops. Yeah. Public getter, private setter. There you go. Using custom getters and setters means Unity can't serialize it, and I don't care about that. If I wanted Unity to serialize it, I would have something like this, where I'd have the public one do this lambda operator, this expression body method, something like that, whatever, whichever the name of that thing is, and then a private one. So it'd be private setter that Unity can serialize, then a public one that just is there. But we just need the public here. So when we check for goal, we update that variable. That's it. So we need to make sure we run that function before our moves have completed, because we're not running it in update. We could also have it return, whoops, not return itself, return is goal here. So if we were getting a bug where we were checking it like a few lines before it actually updated, and that wasn't working, instead we could just like have it run that function whenever we look at the variable, which I don't want to do. So, okay, why is this down here? Moving into scripts folder. Cool. So we need a private, let's use an array because it shouldn't change in one scene load, because we're going to use scenes for levels. Goal target array, goal targets, awake, goal targets equals game object dot find objects of type goal target. And then when the turn is done, whenever that is, we're gonna write a public void check for victory. Check for game end, right? If maybe this game you can't run out of turns, you can't lose, you can just restart. I mean, you can lose, you can get stuck, but the game manager, as far as it's concerned, there's no lose state. You're just stuck. So we'll call that check for victory. That's, I look at that and I'm like, I'm going to rename that eventually. But for now, that's what it's doing. So reach goal target GT in targets. Victory equals false. For every goal target, run return targets if gt.atGoal is false. If they are not at a goal, then what are we doing? If only one of them isn't at a goal, then we have not won. So we'll keep our state on the fragile one, and then the second we get to one that is not at the goal, we will set victory to false and break the loop. Why don't we use link? Why don't we do this the fun way? Bool victory. So that code works. Working code. Delete. Bool victory equals goal targets dot all using system dot link, and then x dot goal. So if all of them are, and this is like an iterator variable, or goal target. I can make that. Yeah, link. Okay, that's some fun syntax. That's very easy to read. Dot all at goal. I mean, it's not super easy to read, but if you use link a little bit, you get used to it, and it's great. If victory debug.log, we win. Cool. Let's test this with a little context menu. Little context menu thing here. Not one. There you go. Every once in a while, Unity just needs a little extra help. So we take our player. Your videos are too long. Well, if Unity loaded faster. So if I go to our game manager here and I have not won, I check for victory, not won. But I do it again, right here, check for victory. We win. Great. So how can I get this game manager to know about the when the turn ends? So what is responsible for when a turn is over? Well, the turn manager is. Turn manager executes it, adds it to a list. This line 18 here won't be finished until all of the commands inside of it, if we're using a multi-command or a move or a push block, until all of these things have run, all of those will get a chance to update the goal conditions. So the turn manager makes the most sense. Tell the game manager to update. Now, to check for victory. So we could do exactly that. We could get a reference to game manager and we could check it for victory. But we're not going to. We're going to use an event system because that's going to allow us to make sure that the turn manager can exist and our game perfectly can run even if there's no game manager in the scene. If there is a game manager in the scene and we put one in game manager in the scene, then there probably should be a turn manager too. Turn manager seems to be more particular, right? Really, there should be both, but here I'm prototyping and everything works fine and I don't have a game manager. That feels like the less important thing. Turn manager, like you won't even move without this. So making things dependent on this feels fine. Feels less, troubling. Troubling? I don't know. You're going to have dependencies. You can't program without them. Otherwise, nothing can do anything. So let's use an action. Let's use an event. Public action after turn event, turn executed event, and after undo event. How about that? After turn executed event, if it's not null, if it has any listeners, we will invoke it. And after undo event, we will invoke that as well. We can write this in one line of code if we want, but it's not. Game manager, void on enable. We could probably just make it the event static. Let's just do that. So even if there are multiple turn managers in the scene, having the game manager check for victory more often isn't dependent on the number of turn managers, and there only should be one, but even if there were more than one, that wouldn't break the game manager, right? It would just check it more often. That should be fine. So we'll make it static. Turn dot after turn executed event plus equals check for victory and dot after undo event. Should we be able to undo our way out of a win state? Maybe, maybe not. But if the blocks don't fit, we should still update. So let's see if we can get these messages spit into the console. If we didn't make it static, we just have a reference to the turn manager and the game manager, and we just drag and drop it or do a find object of type. Or I'd probably drag and drop it, honestly, because I don't want to, I was thinking about moving the turn manager to the player object. Does that kind of make sense? Maybe not. What makes sense to you? Do it that way. Look at all these things we have not won. We win. Amazing. And if it feels like that's a lot of debug messages, keep in mind that we're not checking this in update. We're only checking this when we move. Pretty nice. So we were able to implement event systems in a few different ways to allow our game to just have nicer dependencies. We use a static event system. We just put a game manager in the scene and it works. I don't even think we need a turn manager anymore because it's static. I mean, if we don't have the turn manager, I won't be able to play it, but. So now I need a game state so I can stop moving after I've won and I can keep count and I can see how few moves I can win with. But that's my, why's my restart not working? Didn't I have I did write a level manager script, didn't I? Have I not used that once? It's just nice to be able to restart the game without leaving and reloading Unity. So I tend to put that in my projects pretty early. Like if I mess up testing. I am victorious. Cool, that's all this video is gonna go over. Just a short video on some real life use of a what's it called? Event systems of events. We've got some more refactoring to do. So a little preview of where I'm going to use this project in the future. We're going to use the state machine on the game manager, something we have used before in some projects. We're going to do it here, so we have this nice clean example. And we're going to use probably an interface, but we're going to use another more general win condition. So instead of everything meeting just these specific goal targets, we're going to have anything that can be a win condition. And then we can have our turn manager be a win condition, and you can have a maximum number of turns you can take. And we can have our player be a win condition. I don't know. You could have other objects in the scene that are different blocks that need to be touching, and you can just write your own little code, give them a win condition interface, and we're going to use that. So that's cool. But that's next time. This little project to demonstrate a couple of neat architectural patterns with videos about each pattern is coming along. And if you have been following along, you already got a working Sokabon game. That's awesome.